Hello mga kamatiks! We are now in Quarter 3, Module 8, Lesson 1 to 4, Implicit Differentiation. We have here the learning competency. Illustrate implicit differentiation. The objective: illustrate and use implicit differentiation to calculate dy over dx for the equation. Okay, so we have here the concept notes. Finding dy over dx by implicit differentiation. Differentiate each term of the equation with respect to x, treating y as the function of x. Move all terms involving dy over dx to the left side of the equation and move the other terms to the right side. Factor out dy over dx on the left side of the equation. Then divide both sides of the equation by the factor that multiplies dy over dx. We have here an example. Use implicit differentiation to calculate dy over dx for the equation x squared multiplied by y to the power of 6 is equal to 1. From the given equation, we are going to use the differentiation rule, which is called the product rule. Okay, so we are going to identify the value of u, which is equal to x squared, and the value of v, which is equal to y to the power of 6. Okay, so we have here the solution. Remember that the product rule is dy over dx is equal to u multiplied by derivative of v plus v multiplied by derivative of u. So you are going to substitute. Okay, so the value of u is x squared and the value of v is y to the power of 6. So we have here x squared multiplied by derivative of v, which is y to the power of 6, plus v, which is y squared, multiplied by derivative of u, which is x squared, is equal to the derivative of 1 over dx. Then after that, you are going to simplify. X squared multiplied by y to the power of 6. So we have here the derivative is 6y to the power of 5 dy over dx plus y to the power of 6 multiplied by derivative of x squared over dx is 2x equals derivative of 1 over dx is 0. Remember that derivative of any constant number is equal to 0. Then simplify. We have x squared multiplied by 6y to the power of 5. The result is 6x squared y to the power of 5 dy over dx. Then y to the power of 6 multiplied by 2x. The result is positive 2x y to the power of 6. When we are going to transpose, the result is negative 2xy to the power of 6. Since the coefficient of dy over dx is 6x squared y to the power of 6, we are going to divide both sides of the equation. So the result now is dy over dx is equal to negative 2xy to the power of 6 over 6x squared y to the power of 5. Then simplify, so the value now of dy over dx is equal to negative y over 3x. Example number 2. Use implicit differentiation to calculate dy over dx for the equation x squared plus y squared is equal to 4xy. Okay, so we have here the solution. From the given equation x squared plus y squared is equal to 4xy, we're going to find the derivative of x squared over dx plus the derivative of y squared over dx is equal to 4 times the value of u times derivative of v plus v derivative of u. Since the value of u is equal to x and the value of v is equal to y, we have here x derivative of y over dx plus y derivative of x over dx. Okay, so the derivative of x squared over dx is 2x plus derivative of y squared over dx is 2y dy over dx is equal to 4 times x derivative of y over dx is dy over dx plus y. Derivative of x over dx is only 1. So 1 times y, that is y. Okay? Then after that, we are going to factor the constant on the left side. So the constant on the left side is 2. So we have here the factor 2 times x plus y dy over dx is equal to 4 times x dy over dx plus y. We have here the constant 2 for the left side and 4 for the right side. When we are going to divide, so we have here 2 times x plus y dy over dx divided by 2. The result is only x plus y dy over dx is equal to 4 times the quantity of x dy over dx plus y divided by 2. The result is 2 times x dy over dx plus y. Okay, then after that, we're going to combine all similar terms. Okay, so when we are going to distribute the value of 2 to each of the term inside the parentheses, it becomes 2x dy over dx plus 2y. Okay, so the value of x for the left side, we are going to transpose that 1, it becomes negative x. So the remaining value now of the left side is y dy over dx. For the right side, we have 2x dy over dx. When we are going to transpose that 1 to the left side, it becomes negative 2x dy over dx. And the remaining value for the right side is only 2y. Minus the value of from the left side, which is x, it becomes negative x. Then after that, we are going to factor the value of the left side. So the factor of left side is y minus 2x. And the common factor is dy over dx is equal to 2y minus x. So meaning to say that we are going to divide both sides of the equation by y minus 2x. So y minus 2x dy over dx divided by y minus 2x, the result is dy over dx is equal to 2y minus x over y minus 2x. So that is the result of the implicit differentiation. Okay, so we have here more example. Use implicit differentiation to calculate dy over dx for the equation x to the power of 10 minus 3x squared plus x is equal to 2y to the power of 8 minus y to the power of 5 plus 5 times y squared. Okay, so we have here, note that this type of equation, the left side is an expression that involves only the variable x, while the right side is an expression that involves only the variable y. We can write like this one. So the derivative of x to the power of 10 minus 3x to the power of 2 plus x over dx is equal to the derivative of 2y to the power of 8 minus y to the power of 5 plus 5y squared over dx. Okay, so derivative of x to the power of 10, that is 10x to the power of 9 minus derivative of 3x squared is 6x plus derivative of x is 1 is equal to the derivative of 2y to the power of 8 is 16y to the power of 7 times dy over dx, since that is the variable is y, minus derivative of y to the power of 5 is 5y to the power of 4 dy over dx plus derivative of 5y squared is 10y dy over dx. Okay, since the common factor of the right side is dy over dx, so we have here copy 10x to the power of 9 minus 6x plus 1 is equal to the factor dy over dx multiplied by 16y to the power of 7 minus 5y to the power of 4 plus 10y. Remember that the coefficient of dy over dx is 16y to the power of 7 minus y to the power of 4 plus 10y, meaning to say we are going to divide both sides of the equation by 16y to the power of 7 minus y to the power of 4 plus 10y. So the value now for dy over dx is equal to 10x to the power of 9 minus 6x plus 1 all over 16y to the power of 7 minus 5y to the power of 4 plus 10y. Okay, so another more example. If x squared plus y squared is equal to 25, find dy over dx. Okay, so we have here the solution. The derivative of x squared plus y squared over dx is equal to the derivative of 25 over dx. Okay, so derivative of x squared over dx plus the derivative of y squared over dx is equal to 0 because the derivative of 25 over dx is equal to 0 based on the constant rule. Okay, so the derivative of x squared over dx is 2x plus the derivative of y squared over dx is 2y dy over dx is equal to 0. Then we are going to transpose the constant, which is 2x. Okay, so the remaining value of the left side is only 2y dy over dx is equal to negative 2x. And remember that the coefficient of dy over dx is 2y, so meaning to say we are going to divide both sides of the equation by 2y. So the value now of dy over dx is equal to negative x over y. We have here the example. Find an equation of the tangent to the circle. Given is x squared plus y squared is equal to 25 at a point 3, 4. So we have here the solution. At a point 3, 4, we have x is equal to 3 or x sub 1 and y sub 1 is equal to 4. So dy over dx is equal to 3/4. Okay, so an equation of the tangent to the circle at 3, 4. So meaning we're going to find the equation of the tangent line. Okay, so if you are going to draw the point 3, 4 is located at quadrant 1. If it is quadrant 1, so the graph is increasing to the left side. So meaning to say the slope is negative. Okay, so given is the slope and 1 point, so we're going to use this 1 point slope formula, that is y minus y1 is equal to slope times x minus x1. Since x1 is 3 and y1 is 4, so we are going to substitute that one. It becomes y minus 4 is equal to negative 3/4 times x minus 3. Negative 3/4 because the slope of this line is increasing to the left side. Okay, so simplify. So we have 4 times y for y minus 4 times 4, that is 16, is equal to negative 3 times x, negative 3x. Negative 3 times negative 3, the result is positive 9. Then we are going to write in standard form of an equation. So we have 3x plus 4y is equal to 9 plus 16. So the result of the given equation in standard form is 3x plus 4y is equal to 25. Okay, what's more? Use the implicit differentiation to calculate dy over dx for the equation. Okay, so we have here 4 exercises that you are going to solve. Thank you for listening. Do not forget to click the subscribe icon for more updates on my video.